So we have discussed what is experiment, we have discussed what is scenario, we have discussed what is measure of effectiveness. But still we did not discuss how actually we are utilizing the output from a simulation model to make a justified decisions. So the following section would deal with the following question. So, as we catch up, we evaluate multiple scenarios using the same model and the same measures of effectiveness. A following picture demonstrates the overall approach. So, as example, receiving the results, we are demonstrating them to the decision makers. A scenario 0 represents the current state, while scenario from 1 to 3 reflect different design or policy alternatives. Based on quantitative results and trade-offs, one scenario is recommended, one is considered discussable, and one is not recommended. Our role as analysts is not to decide, but to provide transparent, evidence-based insights from simulation and measures of effectiveness to support decision makers. So as you catch up, we are here to assist stakeholders. And first of all, we need to deliver them the results of the simulation. But to deliver the results, first of all, we need to make, I would call it, a technical work. So meaning that we need to establish a data collection strategy. So a data collection strategy includes number of items, and as you see, some of them are in a gray color, meaning that following aspects of data collection strategy we are going to discuss during the next topic, while for now I would probably stick with the last bullet, which indicates how data from the model will be collected. So maybe for you it seems like a really very simple question because you saw some, let's say, examples of how actually the model is working, and you have already tested XtendSim and a vSim simulation. But to be honest, there are I wouldn't say quite a lot, but still there are different ways of how we could collect the data and record the data. So as you see, the first approach says manually, meaning that, okay, we could take, I don't know, the Excel, and we could manually just copy paste the data from the model to our Excel. Some of the software tools have internal database, so which allows to collect the output from the simulation model and then, at example, to export in Excel as example. Also, some of the simulation tools allows to link external database and collect the data to the external database for analysis. A following option, so usage external database, is really very useful when we are talking about such technology as digital twins. And of course, we could utilize different kind internal data processing tools, so data visualization tools, which in many cases are already built inside the simulation software. So when we have defined our data collection strategy and actually collected the data, the next step or the next stage would be a data processing. So data processing turns raw simulation outputs into meaningful evidence for decision making. First, we collect output that are aligned with our selected measure of effectiveness. Then we clean the data by removing errors, incomplete records, or cleaning the data from outliers. Next, we aggregate the results using measures such as average, minimum, maximum, median, or confidence interval to summarize performance across multiple runs. Finally, we visualize and present the results in a clear tables or charts to support comparison, interpretation, and justified decisions. So probably you catch up that it has been stated that we are aggregating the data across runs. And here I again would like to remind you that usually we are utilizing a simulation model when we have a randomness in a real system. And in order to reproduce the randomness, which, as it has been stated, exists in a real system, of course, we are including randomness inside the model. And if randomness is included, probably you can remember from our previous topic, the model will produce a bit different results. And as you catch up, when we are running the specific experiment, we need to run the following experiment not just one time, but the specific amount of the times. Again, how much we are going to discuss a bit later. Therefore, an aggregation stage is important one, because if you would demonstrate as stakeholders the table with, I don't know, 25 runs, please believe me that as stakeholders would be really very, very confused. And for you, it will be really very hard to explain what a following table means. So, after data processing, we are coming to the next stage. How to present results to a stakeholder. So, presenting simulation results for decision making actually means that you need to select a specific visual format which would best fit to your audience and purpose. It could be tables if you need to demonstrate the specific values. It could be different kind of charts and graphs if you need to present trends and comparison. It could be different kind infographics for communication to non-technical stakeholders, or it could be 2D and 3D animation which illustrates system dynamics. Ensure that measures of effectiveness can be easily compared across scenarios and report both positive and negative results transparently, as both are equally valuable for informed decisions. In your conclusions, spend about 20% summarizing what was done, the aim, approach, and scenarios, and about 80% of your conclusions should be dedicated to insights and recommendations. So a following example is again a copy-paste from the real project which we have conducted for one of our clients. I wouldn't state that this one is, let's say, the best example of how the output from the simulation model can be represented, but my apologies if you are not able to understand what is reflected here. But the story is that this one was a specific request from our client. So in overall, what you are able to see here, you are able to see that a specific measure of effectiveness, in this case a driving time, is represented for a specific parts of the network across different scenarios. And as you're able to see in some of the cases by green arrows, there is indication that probably a following measure of effectiveness is decreased compared to the base scenario. Okay, one more realistic example. This one is from the project which we have implemented for Riga International Airport, and in this case probably you are able to see that we are not producing numerical results because it's too much of them here, but what we are doing, we are visualizing the following numerical results. So I believe it's quite clear that a red color indicates some problems, some issues in the transport network, while the rest, I mean yellow and green color, indicates the specific level of the service. So just to conclude probably a discussion, I would like to state that I can provide you only some recommendations, but each simulation project is unique. Your customers are unique. They have a specific level of knowledge. They have the, let's say, idea of how things shall be represented. That's why we should use a whole spectrum of possible tools, again, tables, animation, charts, or whatever, with a goal to deliver the results of the simulation in a most appropriate form for a decision making.